Hello from the Basler headquarters in Germany. Thanks for joining us today. My name is Katrin Martens from the product management team here at Basler, and I will guide you through today's webinar on multispectral and SWIR technology. But before we start, your mic will be muted throughout the presentation and the rest of the webinar. But if you have questions, please feel free to place them in the chat box on your right. We will collect all questions and we'll try to answer them in our Q&A session after the presentation. If we still have some questions left and we are running out of time, we will make sure to follow up via email after the webinar. We also prepared a very short survey, so we kindly ask you to answer that one after the webinar has ended. But back to our topic and speaker of today's webinar. We can't see what we can't see. I guess we all agree on that one. But thanks to multispectral and SWIR technology, cameras can see what our human eyes is not be capable of seeing. So both tech trends will make us be capable of fulfilling vision tasks which we cannot even imagine yet. So therefore, I'm pretty excited to talk about this topic with you today. So we will show you some differences between multispectral and SWIR. We will show you pros and cons of each, and we will give you some food for thoughts on suitable applications. But don't be afraid, this is not going to be a sales pitch, but an interactive technology session. So we would like to spark your interest, and we might even find some partners for future discussions and collaborations. Now, I would like to introduce to you our speaker, Ingo Leverett. Hi, Ingo.
Hi, I'm very excited.
Me too. So Ingo is always seeking for new and disruptive technology, which actually brings customer value. As head of our innovations department, he always seeks for new trends and combines them what we already know today. And now it's time to hand over. Ingo, the stage is yours.
Katrin, thank you very much. Yeah, hello to everyone out there in the world. I'm happy to have you here, and I'm happy to give you some words about that very interesting topic. But before I start with that, what a year. I mean, did you expect that the year 2020 will happen like that? Very different to what we expected. To everyone out there, stay safe. I hope you stay safe. And it's not a long time to go anymore. I see the light at the end of the tunnel, and I hope 2021 will become much better for everyone. So good luck. Okay, let's start. I would like to give you, first of all, a short view on the agenda. So I will start with a very short introduction of Basler, our company, for those who not really know us yet. Then I will go through the topic, make invisible visible. What does that mean, with a few rules of thumbs? Then let's talk about basics about multispectral and SWIR imaging. And then I will swap over to some current solutions, so solutions that are already available out there in the market for you. And at the end, we will go over to an outlook, which will be my favorite session then. And at the end, as Catherine already said, we will have some time for questions and answers. So let's start. These are the key facts for the Basler company. We are about something like 800 people at the moment. We learned from our customers that we are the most trusted brand in the industrial camera industry. We are the global market leader for imaging components for computer vision, and we have 30 years of experience. And this is always insight-driven innovation. And that's where I'm coming from. I'm coming from the innovation department. I'm thinking of the things that are not available yet. More words about that later. Yeah, these are our competencies. You may know us as a camera supplier. So we are experts in image acquisition, and we are experts also in image transmission, of course, and we are also pretty good in image pre-processing, image analysis, We can do consultancy and solutions for you, and we are able to do tailor-made products. And that's an overview about the products, how they look like, and you find several different ones that also came through the innovation departments on that list here. That's it for now. Let's swap over to the topic itself. Question to you, not to write down into the chat, but just for you, is this a good picture? So I was asking myself the same question, and I came to the conclusion, well, I cannot really answer that question because it depends. It depends on what you want to do with that thing. So if that is the original image and I want to do something about it, I may want to, let's say, sell that apple to my neighbor or so, and then I may do some post-processing to make that image look a little bit nicer, a little bit more color, a little bit more contrast, this and that. So increase the beauty of that picture. But the problem is the information that is not inside of the image cannot be enhanced, cannot be improved. I cannot make it more beauty or more visible. So if I'm going to be a person that is working in the industrial vision area and my computer vision application has a certain purpose, then it makes sense to change the environment and the camera itself and have it prepared so that the things that need to be visible for my purpose become visible. For example, here you see an apple, there's a pressure point on it, and that's damage, so I cannot really sell that apple anymore. At least it will not last very long. And if that is my application, it's simply not okay to just try to do some post-processing. It's a much better idea to think of what I want to see and prepare the entire environment. So I say the art of industrial vision starts in front of the camera. And that's the way how you make things that are invisible, how you make them visible. So what does that mean? I mean, that's not tricky. You can maybe study for several years how that may work, but it's not tricky. And at the end, that setup preparation is the world of which kind of illumination do you select, which type and position, and which kind of colors or which kind of filters do you use. Also, which kind of cameras are you using, the sensor technology, the positioning, the filters. There's much more about it to make the image look nice and have the content that you want to have. But in this short webinar, we are focusing on these three things: sensor technology and filters and colors, in a sense. Okay, as Catherine already said, this is an interactive session. And I would like to come to the very first survey. Just a moment, I have to prepare something. And I would like to know from you which area you are located. Are you coming from Germany, Europe, Asia, America, or is it a different place? And if that is a different place and you feel free to do that, please put that country you are coming from into the chat. So type it in now. We'll give you a few seconds to add your input. And I would say we wait for something like additional 10 seconds so that you have time enough to input your information. And then now let's have a look, Catherine. How do the results look like? Okay, here we go. So most of you, I see that here, 47% come from Europe. And we also have some others. Let me have a look into the chat if I can see something. I cannot see it, but thank you very much for your input. And then let's go back to the presentation. Perfect. Okay. I have another question for you for this interactive session, which is your industry. So if you're selling into certain industries, please add that information also into your survey. Are you selling into agriculture? Are you selling into food and drinks and beverages? Is your portion of the medical area or pharma, or is there something else? And then into other. 10 seconds to go. Let's see what happens. Okay, here we go. Catherine, let's have a look. Here we go. Oh, I see the point. Most of you have been in the others domain. Okay. So I would, if you would do me the favor, the guys from the other industries, please put that into the chat. That would be very helpful for me. Thank you very much. Okay, let's go back to the presentation. As I was indicating in the beginning, let's talk about some basics. I realized that the topic SWIR and multispectral imaging is not that easy to understand. So if you are a beginner, that's the portion for you. I try to stay as untechnical as possible. So if you are a physicist or somebody who really knows all the bits and pieces about that technology, I have to say sorry, because I try to be untechnical, so I'm sometimes a little bit inaccurate. So I'm sorry for that, but I try to be as easy understandable as possible without being a physical professional. Okay, let's talk about photons first. Photons is a particle of light, a piece of light. So light consists of energy particles in a sense. And these energy particles, they are very, very, very fast. They travel with 300 million meters per second. Meters per second means like it can go around the Earth 7.5 times per second. That's fast. And each of the light particles may have a different level of energy. And if the level of energy is different, this level of energy changes into a different color. So each level of energy has a certain wavelength or a certain color. That's something that you have to know. So this page shows you that human eyes, we humans, we can see photons from 400 nanometer wavelengths, which is violet color, to something like 700 nanometers, which is about red. And if you look to the left here, you can see that the majority of wavelengths that are existing, there's even more. The vast majority of that cannot be seen by humans. It's impossible for us to see it, but they are there. And we will have a little bit of a focus in this webinar to the spectrum that we humans can see. In addition to that, the near infrared NIR area, which altogether goes from 400 to about 1000 nanometers, which corresponds to the sensitivity of our standard silicon-based camera sensors. And we also focus on the short-wave infrared band, which starts at 1000 nanometers, which is outside of the visibility of humans, and goes up to something like 1700, which is a little bit different sometimes, and which corresponds to the band, the sensitivity band of InGaAs-based, indium gallium arsenide-based imaging sensors. So, and if these photons, if these particles hit material, they can be reflected, they can be absorbed, or they can be transmitted, like you can see in that picture. There's a link below the picture. There's a web page where you can find much more information about that. So if you're interested, just click on that later on once we provide that, or make a note and look at this web page. So now this is one of the most important points. The material itself decides how the photons are treated, depending on their energy level. And I call this, for this presentation, material-specific fingerprints. So every material is a little bit different. So some photons may be transmitted at a certain wavelength, and another wavelength they may be absorbed, and the different material is working a little bit different. So it's very material-specific, and that's something which is interesting to know. And my tip for you, it's worth to know the material-specific fingerprint of your material you are inspecting, because if you really know that, it really helps you to make things visible that are invisible or not that really easy to read. Okay, let's go over to that page here. That is sunlight. This curve shows you the sunlight. On the x-axis, we have the wavelengths, so the energy level of the different photons, or the wavelength, you can see it, and that's the intensity on the y-axis. So, and if you have a look at the yellow curve, that is the light, how the light looks like coming from the sun when you are outside of the atmosphere. So if you're going up for several kilometers, close to the moon, for example, you look at that sunlight, it's looking like the yellow one. If you're going down to sea level, then you have the intensity of the red curve. And you can see there's a difference between the red curve and the yellow curve. And that is the material-specific fingerprint, you can see here, of the atmosphere. So at certain wavelengths, for example here, 1400 nanometers, water in the atmosphere is killing almost every light of the sunlight. So you can see other points. This would be oxygen, this is CO2, and you can be much more accurate, but that's what I mean with the material-specific fingerprint. Going to the next page, we come a little bit more specific. So that is a very similar curve. Here we again have the wavelengths, which is now shown in microns because I copied it here from that webpage. Have a look at that. And this is, for example, 0.6 is 600 nanometers. This is the visible range here. And the material-specific fingerprint of the entire atmosphere looks like that. And you can see that here, that the majority of that part is coming from water in the atmosphere. There's some other parts coming from CO2, from oxygen, and from other devices. Here you can see the ratio or the content of that specific material in our atmosphere. So this exactly is what I mean. If you know from your material these kind of fingerprint, then it's much easier to think of what to do to make things visible or to have an easier job in your vision application. Okay, let's come over to the rule of thumbs. So how can you move forward if you have a vision application in front of you? So the first rule of thumb is, well, if you can answer your vision question with a monochrome camera, use a monochrome camera, because at the end it is the cheapest and the most easy way to move forward. So if you can do that, do it. It may help to add color filters to your camera to even make that more easy than before. And your information, the thing that you're looking at, needs to be, then it's coded into gray level in intensity. And the typical questions in this example here with the gummy bears is like, okay, how many gummy bears do we have here? I want to count them. Or, what's their size or the position or the orientation? Because that's something you can read out of that image, and you don't need that color picture for that. Color means 3 times more data at the end that you need to handle. So try to stay monochrome if you have the chance. So if you realize in your application that the monochrome image doesn't provide you the answer on your question, then you should think of a color camera, or, and that's also a rule of thumb, if there's human operators inspecting the images or making decisions on that image, it's a good idea to try a color image, because humans like color images. We are seeing color images, and the more the color of the camera image corresponds to what I really see, the easier the job is for me. So the questions could be like, which are the green ones, or are the colors equally distributed? Well, it's not possible for me to understand that from the black and white image. If I take the color image, then it's much easier. Next page. Okay, you have tried your color camera and you realize that the color camera is not good enough. You cannot really differ between the colors that you want to see. You even have problems to do that with your human eye. So it's going more specific. It's going beyond a standard color camera. Okay, so then try multispectral cameras, because these cameras give you much more freedom to exactly define which colors you want to look at. Questions like, are my colors inside spec? Or what is the exact color I'm looking here? Or for the next page, where is my target material? I've got from the company Bader, which is very close to Hamburg here. That's close to the Baltic Sea. They are fish inspectors, and they provided me with this image here, for example. So they are doing multispectral imaging to find the positions of fat in the fish meat for the following processing steps. So thank you, Bader, for providing me that image to show it here. For more information, just click on the link below or write that down and have a look at their website. Okay, here we go for available solutions. So what is existing today if you want to go multispectral? First solution that I can recommend to have a look at is cameras with a beam splitter inside. You can see that here in the image. The white light is coming in, and that beam splitter is dividing the white light into different wavelengths. You can design that beam splitter for your special purpose. Yeah, and the pros is, well, if you have a camera based on that technology, you can do simultaneous imaging, which is really nice if you have moving objects. But there's some cons involved, and the cons are it's pretty inflexible because if you have decided for a certain type of colors that you want to look at, you cannot change it anymore. So you need to have a new beam splitter designed for you or buy from somewhere if you want to change the colors. And also this thing makes your camera pretty bulky because at the end there are 3 cameras in one body together with that beam splitter makes it pretty heavy and big. So the next picture is active illumination, which means you add light sources with your favorite target colors and multispectral imaging to your system. So and you can have as many light sources as you want with the target wavelengths as you want, done by LEDs or by color filters or whatever. And this has some pros because this gives you a lot of flexibility. So if you want a different light, you simply exchange the light source or the color filter in front of that. And it's good. Coming to the next pages, there's like in the previous ones with a beam splitter, there's no moving parts, and no moving part means it is good for the long-term durability because whenever something moves, it's mechanical movements. And that's not good for the long-term durability. But there's some cons, unfortunately. You can only do sequenced imaging. That means you have to turn light source, you turn on light source number 1, do your image, turn on light source number 2, do your image, and that makes it coming into a sequence. And if you have moving objects, then your objects may be at different positions or in different situation. And then you want to do multispectral imaging with that. It's not really nice. And there's another con, you need to do extra devices. So you need something like a controller, which turns off your light sources and work together and sync it with your camera system. So coming over to one of the very famous ones, I've seen that very often, is the filter wheel solution. You use a standard monochrome camera and you put in front a turning wheel. And in that turning wheel, there are different color filters involved. And once the color filter passes the camera can look through that filter. And by that, you can do multispectral imaging. The problem here is, the pros are that it's very flexible. So different color filters are easy to implement. If you want to use different numbers, you may need a different plate, but it's easily exchangeable. There's also some cons, as in beforehand, you have sequenced imaging, so you can only do imaging in a sequence, and you have moving parts, so there's a turning wheel. And it's a little bit tricky if you want to do asynchronous triggering. So if the sequence or the scenery needs asynchronous, not frequent triggering, then you may get into trouble to accelerate and to stop your turning wheel accordingly. So there's another technology which is called liquid crystal tunable filter, LCTF. Unfortunately, I only found a pretty old picture here, but that's showing pretty nicely what I'm talking about. So instead of having fixed and pre-processed optical filters, you can also do a tunable filter. Tunable filters change their behavior depending on the voltage that you apply to that system. And if you insert it directly in front of the camera, that's the camera body, and if you implemented it right in front of the sensor, you are able to, change your optical filters by means of voltage. That's giving you a nice flexibility because it's voltage driven, and you don't have any moving parts anymore. That's nice. But there's also some cons, means again, it's sequenced imaging. So once your object is moving, then you may get into trouble. And I must be honest, the tunability is nice, but the tunability is also limited. You cannot do each and every color filter of your imagination by applying a different voltage. So that systems only provide you with certain solutions. And if that solutions are fine with you, everything is nice. Otherwise, it's getting problematic. Okay, the next also very famous is the Pushbroom solution, and I found very nice documentation on the websites of JAI. That's an area scan camera. The Pushbroom solution is an area scan solution which behaves like a multicolor line scan camera. So inside that area scan camera is a prism and some other tricks, and that is spreading the light information into many different color information. So the nice thing about that solution is that you get a lot of flexibility here to define which kind of target color you want to look at, because you can simply select it by means of settings, software settings. And you have a lot of color resolution. As well, here there are some cons. That's a line scan camera at the end of the day, and that line scan camera needs to scan your object. And as that object needs to be scanned, it takes some time to scan that thing. So it's a little bit slower than the other solutions. And if your object is moving during that scan, it's getting really problematic, maybe. So have that in mind. Okay, the next also very famous solution is the filter array on the sensor. Also here, I would like to recommend to look at the websites of JAI because they have done a very good job explaining that here. And these are images inside of the camera that are coated with a special multicolor pattern, like you can see here. That's nice. So there's some pros behind it because you can do simultaneous imaging. So all the colors you can that are provided by that sensor are acquired on the same point of moment. So if you have moving object, it's not really a problem. And this makes the camera and the entire setup pretty small and lightweight if you need that. There's also some cons. That's also giving you limited flexibility. So if that sensor is not providing you with the colors that you want, you need another sensor, and you know how expensive that may be to build another sensor. So you're pretty limited there. And also, what is more, the more filters you have on that sensor, the more your spatial resolution is reduced. So that's a trade-off here. But again, that's also a solution that is available out there. Okay, coming over to the next interactive session. Question to you now is, which of the following types of multispectral cameras, if you use it already and or if you are intending to use, is your favorite? Is it the beam splitter solution? Is that this thing with active illumination or with multiple lights? Are you more the friend of the filter wheel or the LCTF solution? Or are you a friend of the Pushbroom solution? Or is there a multispectral solution, another multispectral solution that is in your mind? Please type it in now. You just have to take part if you have an opinion. If you don't know, if you're not a multispectral guy and you have no opinion, just leave out that survey. So I give you another 10 seconds to type in your data, and then let's see what the result is. Okay, Kathleen, let's have a look. Okay, here we go. So I just see that the multiple light solution is on place number 1 on this, and the beam splitter solution is on second. Or is it the push broom? It's the Windows pretty low. The push broom seems to be on place number 2, and then followed by the beam splitter solution. Thank you very much. By the way, if you have typed in other, please do me the favor, if you want to, and type your favorite solution into the chat if you want to. Just do that now. Thank you very much, Catherine. Let's go back to the presentation. Okay, we have another question for you, which is how many color filters are you using or are you intending to use? So it's again the same question for the people who are dealing with multispectral imaging. Are you dealing with just one very specific color, or is it in the range of 2 to 3? Are you in the range of 4 to 8, 9 to 15, or is it even much more than that? I know if you have multiple applications, then it's a little bit tough to type something in, but please decide and just type it in now. You give another 10 seconds to do that. Let's see what the result is in a few seconds. Okay, Kathleen, let's have a look. Here we go. Yeah, thank you very much. The majority of you is using low numbers. So I would say something like more than 50% are dealing with low numbers between between 1 and 8. Yeah, thank you very much for your input here. And then I would say let's go back to the presentation. The topic we haven't touched yet is the topic SWIR, short wave infrared. And I like that topic very much because this is something that increases the range of visibility. That camera is looking in the invisible range for us. So coming back to the rule of thumb, if your answer cannot be found in the visible range, so if you realize, well, I cannot see it because the difference that I want to see is not in the visible range. Thinking of the material specific fingerprints. So if the differences of your materials that you want to differ between are in the non-visible range, SWIR may be your answer. And again, if you add color filters, that would make your life even easier to enhance the contrast. Again, here, the information is coded into grayscale. And you could ask yourself, or you could answer questions like, where's my target material? So I'm looking for, like you can see here, salt and sugar. Where's my sugar? Where's my salt? Or is the ratio of both okay before I mix it? Something like that. Next interactive question to you. That's about SWIR. What are your pains? If you are in SWIR imaging today already, what are your pains? First choice is it expensive? Or maybe even too expensive to use it? The pixel resolution is too low? Or the image quality is limited? There's this and that inside the images and that makes it tricky. Well, I need a visible or SWIR solution, so something which covers both. Or is there something else, or even no pain? So if you're very happy with that, or if you have something other to tell us, just mark the other button. And again, if there's something in the other button and you would like to tell us, please put that into the chat. But first of all, type in your selection, give you something like further 10 seconds to go. And then let's have a look at the results. Okay, let's have a look. Whoa, okay, that's pretty interesting, but I must be honest, that's something that I was expecting. The current SWIR imaging solutions are very, very expensive, and that's something which is, I can understand, a pain to many people. Yeah, thank you very much. Let's go back to the presentation. Okay, if multispectral, no, if SWIR, the standard SWIR doesn't really help you and you want to, for example, differ between many materials, then it may be tough to get along with standard SWIR. And then you can also do multispectral SWIR, why not? To gather pictures like that. On the left side, you see these two pictures. The upper picture is what humans see with all the different, with the blisters, with all the different liquids inside. For the humans, they are all looking pretty much the same. You can try to smell or to taste to see what the differences are and to find out where everything is. But if you go into multispectral SWIR, the story becomes much, much easier. I've integrated for you some wavelengths for this example, what you could do. And by that, it's much easier to find out which material differs how from which material and if it's on the right position. So here the information, like in multispectral imaging, the information is not coded into gray level, it's coded into a color vector as well as gray level at the end. And this gives you much, much more freedom to do your application. You could answer questions like, oh, which of all these, which certain material, and I have many of them, do I see here at which position? And if before I close the blister and sell it to somebody, are the liquids at the right position? Would be a mess to be untidy here. Yes, that's it. Some more information about multispectral SWIR, some impressions. This picture here shows something out of our laboratory with devices that have been blue because we wanted to see if something that changes, that is not easy to distinguish between because of the same color, if it's much easier to do that maybe in a different color domain. And you can see here, that's the same setup. It looks entirely different. And here it's by the color means and also by contrast means in several cases much easier to do your inspection. What you also can do with SWIR, many of you may know, is also to do some limited thermal imaging. So for temperatures going higher than, I would say, 200 degrees C, the SWIR technology becomes sensitive to that technology. So you can see temperature here in the image, that's a hot soldering iron. We have also put hot coffee into that cup. Unfortunately, 2-digit or let's say liquids below 100 degrees centigrade is something that you cannot easily see here. You may use some tricks, but it's not visible. And the message here is with SWIR, you can do a mixture of imaging and color imaging even and temperature. You don't need an extra thermal camera with that. You can do both at the same time if you have temperatures that are high enough. And looking at paper money, that's in the application of, let's say, print inspection. Paper money, at least the European ones, are full of security marks. And it's amazing to see what you can see outside of the visible range. For example, here we have used in the SWIR picture different colors. The red channel is the same as on the left side, but we have selected two other ones coming from the high SWIR range. And there you can see that the picture looks entirely different. And the watermarks and the security marks partly disappear, partly appear, and gives you much more freedom to do the inspection if you wanted to. Okay, that was the part of the existing stuff and a little bit of knowledge transfer, and I'm coming over to the future. That's the outlook of the company Basler. So what's coming up next? I must be honest, we have found something interesting, and that thing that we have found is far away from being a product. So it's an early prototype stage. And I unfortunately cannot disclose yet what it is. But what I can tell you is that Basler is having an open innovation program running. And the open innovation program means that once we think of very crazy new stuff, which is not existing yet, and using very new technology and have some inventions and some patents and things like that, that we need to share that idea or the early status prototypes to customers that are potential target customers. And we need to share that idea to these guys to understand if we are going into the right direction. So before we build a product out of our ideas, we want to have contact to the people that may be customers in the future to show it to them and to understand if we are on the right way or if certain things have to be changed and modified. We also may select lead customers and lead users in that phase as well. That's the reason why it's called open innovation. So there is a chance that one of our contact persons becomes somebody who is getting this product first for tests and for, giving us feedback and things like that. And the question to you is, do you want to join? Are you interested in contacting us, talking with us about the ideas that we have, and maybe test prototypes and go into your laboratory and see how good it works in your application and spend some time together to see and to modify the product so that they really are perfect for you? Do you want to join? If yes, there will be a survey at the end. You can type that in, or you can send me an email at thinktech@baslerweb.com. And if you're interested, and I would be very happy to see a long list of interested people. And now it's time to come to the question and answer session. Thanks for listening.
All right, thank you, Ingo. We got quite a number of questions here. So I would like to start with the first one.
Okay.
We have it here. Do you see multispectral or hyperspectral SWIR cameras becoming cheaper in the near future? If so, could you give an indication of a price drop in the next 2 years?
Okay, hyperspectral SWIR cameras was the question, right?
Hyperspectral and multispectral SWIR cameras.
Okay, SWIR cameras, yeah. Well, at the end, we have seen that at least the SWIR solution are very expensive. And I know from many, many customers, that's even a reason not to even touch and test the SWIR domain because it's simply much too expensive. And that's a pain that we've learned of. Unfortunately, I cannot disclose so much what we are working on, but we try to address that significantly. And well, I must say there's a lot of room to make things cheaper in this multispectral and SWIR domain, so that I guess once the first player is doing something about that, prices will drop. So I'm sure prices will go down once new technologies allow that to do.
All right.
Okay.
Another question here, I think you might have answered that already. Will Basler going to manufacture SWIR cameras?
Well, it's too early to say that. I mean, you have seen that in our pictures here. We are working on something, but decisions have not been made yet to really launch that, and it's a long way to go. And as I said, in the Basler Open Innovation area, we need contact to customers first to really prove that the things that we think are helpful out there in the market are really worth doing it. So without having customer contacts, we will not do that decision anyway. So the way is long to go, but yeah, we are working on something. Unfortunately, I cannot disclose more than that. Sorry.
That's a cliffhanger.
Yeah.
Okay. Next one. Can you provide me some more information about the Basler Open Innovation Program?
Yes. Yes, what can I say? I mean, it's many people have an innovation area, and in that innovation area, you try to define or find ideas of new things that you could do. And our Basler Open Innovation Program is basically the program of talking to potential customers and to potential users of our idea, which always need to be integrated into our innovation work. So my team and the process I'm working in is in a very early stage, more or less comes right after the radar phase, where we just scan the market for new technologies and problems we can see. And then we start working on an idea, and then we are looking for people who can tell us if that idea is worth for them, if it really fixes a problem to them. So even before we even do prototypes or running products, we go out there and talk to the people. And that's and the voices of those users and of those customers are integrated into the product design. So we would build prototypes for tests, and so that customers and users can even try out if this really works, and or if there are further dogs around the corner that makes the product unsuitable. We'll talk about pricing, about all the functionality and all these different things. And open innovation means that you do not design the things yourself and go into your war room and think of ideas and simply make them happen and come out with a big bang. No, our Basler Open Innovation Program means that we have customer contact all the time, and also lead users and lead customers that are really involved in all of our procedures before the product becomes available in the market. Yeah.
Okay. Next one. How should illumination be used with SWIR imaging? We are using it to look for hot objects, but would like to look for moisture too.
Okay, so let's see if I can get that. Okay, you could see in the let's see if I can open that up here. That was the sunlight diagram. There are certain wavelengths where water is becoming very obvious. So, for example, at 1400 nanometers, this cup of water would be looking like coffee. And if you use these wavelengths, then you can work on making water transparent or water visible, or seeing wet things. And if you want to see temperature at the same time, basically you do not need any additional light source for that, because that's enough light coming from the hot iron or from the hot material itself. So you need to have a short exposure time on the water image, so that the temperature does not interfere too much, and then a longer image with the temperature of the hot material, with the material of the hot material, right? That's basically it. To explain that in a few seconds is a little bit complicated, but that's the way I would move forward with. Hope that helps.
Right. Okay, some questions are still coming in, so we try to get them answers today. I have 2-micron laser applications. Will you address such issues as a beam profiler? Should I read that again? I have a 2-micron laser application. Will you address such issues as beam profiler?
Beam profiler. Well, basically, I don't know the wavelength now, but at the end, beam profiling is a pretty common application for, it's 2 micron, now I got that. 2 micron is a little bit far out, but I think that can be done, and that's a question I would like to have answered offline, but that seems to be more complicated to explain. But it's, yeah, and it's not like that I can really explain how the future product in detail will look like, because the decisions haven't been made yet, and it depends on which kind of lead user and leads customers we find and which way it is going. But at the end, I don't see a reason why 2 micron lasers cannot be beam profiled by a SWIR camera.
Okay. Next one, which line scan camera would you suggest for moving objects for better imaging?
Which line scan camera?
Yeah.
Well, moving object and line scan cameras always is a problem because the object at the end may look really much deformed. So the basic idea would be much better to use an area scan camera. If it is a line scan camera with a moving object, I would select one with a high line scan rate so that the object can be really quick be acquired, so that the object doesn't deform too much, because movements change the position over time, and a line scan camera needs time to scan the thing. So my first choice always would be use an area scan camera, and if it has to be a line scan camera, make it fast. So if you can use fast cameras with short lines, and so that you have a high line rate to really be quick in scanning over the object, so that the object is not so much deformed. Hope that helps.
Okay. All right, one more. If we are completely new to multispectral and SWIR, what is a good starting point? What kit is needed to get an idea of what can be done?
Okay, well, Basler does not have today SWIR camera solutions nor real multispectral solution. But with the Basler portfolio, you can do products that do multispectral imaging. If you're really a beginner and you do not want to build the solutions on your own, use a Basler camera and apply things that it becomes a multispectral solution, if you do not want to do that, I would look out for the players out there who are experts in that. I mentioned already one, and if you just scan the web, you will find out there's many multispectral suppliers that provide you with a wide variety of different solutions that are ready to use. And I would have, if you're really starting at that point, I would have a look there to really do that. Or you can get in contact with the customer support of Basler and get an indication which way to go with our product portfolio. But that also today it means that you need to assemble things which makes the story for you more complicated, rather than selecting things that are ready to go. Click.
All right. What else do I see here? How can I get not blurred images under the condition that the Basler camera is mounted on a car and trying to capture images from the pavement?
Okay. Two things. First thing, short exposure times. Whenever you have moving objects, or your camera is vibrating, or your car is wobbling around, you need to do short exposure times. Same as with the line scan camera, so that the acquisition is over as quick as possible, so that movements do not really apply into the objects. That's step number one. But then you may get into light or sensitivity problems, because at very short exposure times, you may get into problems that the image is getting very dark, then you increase the gain, and then the image is getting very noisy, and then you have a lot of mess there. You need to have a very sensitive lens, and you need to have a very sensitive camera for that. That's something we can give you recommendations of out of our portfolio. There's one other thing. There's two different types of shutters in the camera domains. One is the global shutter, and one is the rolling shutter. The rolling shutter typically is the cheaper ones. That's nice, but in the rolling shutter, the lines are exposed in a sequence. Like a line scan camera again, means like even if you have short exposure time, a very short exposure time, there's still the rolling shutter effect, which gives you deformations in the image. Looks very strange. And if you have problems like that, you need to look for a camera that has a global shutter inside. There's a lot of global shutter sensors which are really nice, but unfortunately they are more expensive. Also with the lenses, sometimes the diameter gets a little bit bigger, but that's the way to go if you have moving object artifacts. Hope that helps.
Okay. So one more I kept for the last. Can SWIR detect ghosts?
Well, you can see what you can see. dear customer or dear listener, if you think you have ghosts, let's try to find out. That's very interesting to see. I don't know yet, but that would be great if you could make them visible. Let's try out.
Okay, good one. All right. So, unfortunately, our time has come to an end, and we need to finish our Q&A session as well as our webinar. Thank you again for participating and listening and for giving us all the available feedback as well. And everything has been recorded and will be available on demand shortly. And again, before you leave, please answer our survey. It will pop up after we have ended the webinar. Okay, Ingo, any last words for today?
No, I'm happy. I'm excited. I'm looking for your feedback, and I would be happy if we can find in the Open Innovation Program some lead contacts. So please submit your application. Thank you.
Okay. And if you're looking for further topics on our webinars, please feel free to check out our website, baslerweb.com, and you find lots more to see and listen there. All right, that's it for today. Thank you again. Stay healthy, stay safe, and see you next time. Bye-bye.
Have a good time. Bye-bye.